Most students fail IBM's offline coding round, not because the questions are too hard, but because they prepare the wrong way. You might have practiced hundreds of problems like prime numbers, Fibonacci, anagrams, etc. But in the actual exam, you will face something completely different. Questions that look unfamiliar, questions that feel confusing, questions that test your thinking, not your memory. In this video, I am going to show you the exact way to think, the patterns IBM actually uses, and how to decide which data structure to use, how to break down any problem, how to build logic step by step. By the end of this video, you will be able to approach any IBM coding question with confidence. Before jumping into problems, understand this. Coding is not about syntax, coding is about pattern recognition. Whenever you see a question, your brain should ask, what is the input, what I am trying to track, does this involve counting, time or order, range, nesting. Based on that, you pick the data structure. Instead of memorizing, remember this mapping. If problem says count, frequency, most common, then the data structure should be 100% it is hash map. If problem statement involves time intervals, scheduling, then it involves sorting plus arrays. If problem involves continuous range or window, then it is 100% sliding window using DQ. If problem involves events over timeline, then it is sweep line algorithm. If problem involves nested structure or order reversal, then it is 100% stacked data structure. Your job is not to solve instantly. Your job is to identify the pattern. Now coming to the first data structure, hash map, it is most commonly used for frequency counting. When you see most frequent count occurrence, find duplicates, immediately think this is a hash map type of question. For example, given logs of user IDs, find the user with the highest number of logins. The step-by-step thinking would be like, I need to count how many times each user appears. I need a structure to store user and count. This is exactly what a hash map does. First of all, traverse the array, store the frequency in map, traverse map, find maximum. The common mistakes students do is students try nested loops, which gives big O of n square time complexity. IBM expects big O of n using hash map. If counting is involved, hash map is your default weapon. Coming to the next, interval processing. When you see time ranges, start and end overlapping type of questions, immediately think about sorting and interval logic. For example, given meeting timings, find how many meeting overlap. Problem is about ranges, start and end, overlapping depends on order, so first step is sorting. The logical flow would be like, sort intervals by start time, compare current end with next stat, track overlaps. The common mistake student makes is like a student directly try logic without sorting. This leads to confusion. Whenever intervals are given, first step is always sorting. Coming to the next data structure is sliding window. When you see last k seconds, subarray, continuous range, immediately think about sliding window. For example, find maximum number of requests in any 60-second window. Step-by-step thinking would be like, if you apply brute force, you need to check all windows, it will be very slow. Instead, maintain a moving window, expand right, shrink left. The logical flow would be like, use 2 pointers left and right, expand the window, if condition breaks, move left. Don't recompute everything, reuse previous work. That's the logic in this. Students restart calculation for every window. This is the common mistake they make. And we can say that sliding window is an optimized brute force algorithm. Coming to the next, this sweep line algorithm. When you see maximum users at a time, peak load, overlapping events, immediately think about sweep line. For example, find maximum number of users active at the same time. The step-by-step thinking would be like, events have start and end, convert it into timeline changes, like start +1 and end -1. The logic flow would be like, store all elements +1 and -1, sort by time, traverse, keep running sum, and track the maximum. We don't track users, we track changes. The common mistake student makes is trying to compare all intervals pairwise, which gives us a big O of n square complexity. Sweep line converts complex overlap into simple addition. Coming to the next data structure is stack. When you see nested structure, undo operations or order matters. Just think about stack. For example, check if parentheses are valid. The step-by-step thinking would be like, if it is the opening bracket, store it. If it is a closing bracket, match last opening, last in first out stack. The logical flow would be like, push opening, pop when closing. If mismatch, it is an invalid. Stack helps you remember the past in correct order. The common mistake students do is trying to solve without tracking order. fails in nested cases. If order reversal are nested, just go to stack. The most common mistakes overall students do is jumping into code without understanding, not identifying pattern, ignoring time complexity, and not explaining the logic. In IBM, writing code is only about 80 to 90%, but explaining also is required during the interview. The structure you need to follow is problem understanding, approach, code explanation, and time complexity. Don't try to solve 500 questions, just master these patterns, because IBM doesn't test how many questions you solve. They test how you think. If you understand this video, you are already ahead of 90% of students. And if you want, in the next video, I will solve some of the problems that are in HackerRank based questions, which will appear in your IBM offline coding assessment. And also I will put a PDF with most repeated pattern based question in the description. All the best, go crack it. That's it for today guys, thank you.